Today's topic is Swiss knife Apache Pulsar. So I'm just gonna discuss about, not gonna compare completely Kafka, but yeah, I just use the Kafka terminologies, like what uses in a Kafka and how we achieve it using Pulsar, how it's beneficial, and what all things we do. In the starting, we just discussed cloud native features of the Apache Pulsar, and then we just do the short of slides about it. So I use this term Swiss knife because Pulsar has a lot of features which other streaming platform is not providing, and that's making it unique. So it's a Swiss knife. So my name is Vikas. I'm a customer reliability engineer in StreamNative EMEA region. I have a decade, more than a decade experience in IT industry. My specific key skills are JVM and big data. I worked on Apache and contributed some Apache good products like Hadoop, Kafka, and now with the Pulsar. So I see both of the worlds, and that's me. And this is the next presentation based on my experience and how I did find the Pulsar very good. So those who don't know StreamNative, it's founded and founded by original creator of Apache Pulsar and a bookkeeper. We have a large contributor to open source Apache Pulsar, function mesh, function operator, Oxia, which Shiv explained already, numerous Pulsar connectors. We offer the StreamNative Cloud, partner with the software team worldwide to accelerate time to production and the manage Pulsar at a scale. Fully managed Pulsar services with the enterprise feature on a StreamNative and a custom infrastructure. So Pulsar, we already talking about the Pulsar a lot. Apache Pulsar is, so I'm not going into deep what exactly the Pulsar is. Those who don't know, I think my next slide is gonna entertain you and give you the nice experience about the product. And he used the terms here, the cloud native. What exactly making it is cloud native compares to the other solutions? So when I'm talking about the other solutions, let's take an example of Apache Kafka. So Apache Kafka is the Pulsar is very scalable, just like a Kafka, but it's additionally provided elasticity. How we just want to discuss it. It completely and supported on a containerization system. That's making it more cloud native. So if you want to use Apache Pulsar, I would say right things to use it with the Kubernetes environment and the infrastructure that give you more feasible and good functionality. When I'm talking about the event processing system, the two things come in my mind is one is streaming, second is the message queuing, right? So streaming is some sort of real-time example where you need to do the changes, the message flow and the event processing is happening real-time. You will have your producer, your consumer, all the data flow in real time. So all the streaming system should be process your data in order. That's really important. It should inject the large amount of data because we are talking about million messages in a second. Data retention is a key part because we're gonna do the lot of transformation and aggregation on the existing flowing data. It should be able to handle and big catch up the reads because again I said million records in a second, right? So we have to be catch with the big catch up reads. We know Kafka is a good component like which we can use for streaming. Similarly for the queuing, it's not the real time, but yeah, it has its own use cases which it can serve, right? So you can like when I'm talking about the queuing, the main key point is throughput. So you can you have to consume your messages from the existing. So queuing is something like you can compare it with the task queue where your queue contains the tasks. Your worker is running, worker is take the task and it just do the jobs. So to do that, I think to get the throughput, you need to make sure that your consumer you can add the consumer dynamically, you can delete it because we are taking our solution is cloud effective, right? So you should be worried about your cost when you are working with the cloud services. I think you should be worried about cost. You should be easily less scale your application, you can bring it down. So when you are talking about the queuing features with the cloud solution, the key point is add and remove the consumer dynamically. The second is you should not be getting blocked about from your consumer when you're processing the messages and taking it. If you have some failure while processing the records, you should be make sure that it should be redelivered. And last and least, you should be have a schedules or delay delivery because queue can be handled with the multiple timeouts, right? So let's say if I want to send a certain event or certain message for specific timeouts, I need to take care of the define some timeouts which can handle such kind of scenarios. Now what? Pulsar is good, best solution for streaming, and Pulsar also supports the message queuing. So I can say Pulsar is the best of both the worlds. Pulsar till now, who don't know, this can be achievable. And earlier when we launched it, I think people were not having idea, how Pulsar gonna do it. Now, how many know that Kafka start supporting queuing? Yes. So so if somebody follows you, right, which means you are doing good, and we are doing it from past 3 years. So yeah, coming to the next thing. So why Kafka? So I'm not going to compare a Kafka as a solution, but let's see how about the existing system of Kafka doing the queuing and how it's going to help you, and how Pulsar address the common issues of the queue. So this is a Kafka topic looks like, where you will have a topic. Inside that you have partitions. In partition you will have a messages, and you will have a consumer which gonna consume data from your partitions, right? The mapping of the Kafka partition and consumer is one-on-one. So you have the number of partition you have, the number of consumer you can have, right? So here's the common scenario in the Kafka topic looks like when you just running a consumer. Now next, what the problem occurs? What if I need to consume the queue faster? I need to add more consumer. For that, I need the more partitions. And if I add a partition in Kafka, we have a nice time. When I'm saying nice time, people started laughing. I see a smile on your face. Yep. So nice time, which means you're going to have a lot of troubles. Like you have a repartitioning. The next problem, what if a message blocks in a queue? Because your consumer is consuming a message from a partition chunks having a messages events. Let's say I consume the message M01, M02 is got stuck. And let's say consumer is taking a huge time to consume these messages, which means you cannot consume the later messages. What to do now? I think you need a queuing, which so you're gonna add one more consumer as per the previous definition, and again one more partitions. It looks good now. Yes, for consumer one, not for the consumer zero. Still stuck. So you need to simply think those sort of platform is not designed for the queuing. What the queuing need, it should not block existing features which you have discussed in the start. So Pulsar is the simple solution which gonna address the streaming, which is already explained by Mukunda in the start. What is the best in the streaming? Is some features already been discussed by Shiv. Now we discuss about the queuing and the additional some comparison. So this is the basic message architecture looks like, where you have a producer, consumer, and Pulsar. I think everybody can relate it with all other solutions, right? Where producer is no idea what the consumer is doing, who the consumer is no have idea what the producer is, and all the things is being maintained by the Pulsar inside within the topic. What making the Pulsar difference to handle this kind of thing? The point is subscriptions. We already discussed about it, and let's discuss in the more how we're gonna handle it. So Pulsar consumers declares how they want to consume the messages to connect to a subscriptions. And then subscription specify how consumer using the subscription will receive the topics messages. And the next is subscriptions track which message needs to be consumed. And the last end, one topic can have many subscriptions. So there is no restriction around it. We are not saying this topic is only applicable for failure. This topic is only applicable for your exclusive. You can have as many as subscription type for the single topic. So this is the game changer for the Apache Pulsar. So let me explain you how we're going to address those problems we had discussed in the previous slides. Subscription modes. These are the common factors we already discussed, but yeah, let's discuss in a more detail. So producers are producing messages to topic M0 to M4, and the first subscription come into the place is the exclusive subscription, and that is taking care of your ordering. And since it is taking care of your ordering, it is apt for your streaming. Because stream need your ordering in a place. What happened if a consumer is consuming a message with respect to exclusive subscription? Because in the exclusive subscription, we can have a single point of failure. Well, like let's say if your consumer failed, other consumer cannot recover it. We have failure where two consumers are parallelly working and sharing the same data, and Pulsar will take care of this failure. So wherever your consumer one goes, from the same cursor, the consumer two is gonna started consuming. So your application never got stuck. Again, it maintained the your ordering again. So since it is maintaining your ordering, it's good for streaming. Now come back to shared subscriptions. So as Shiv explained, shared subscription is using the by default round robin. So if you want to use this shared subscription, we need to use it with the messaging. So how messaging works is like we use the round robin algorithm to by default to share the data with the consumer. As many as consumer you can have, you will get the messages. But this is not having containing the ordering, right? We cannot do ordering with this. So that's a shared subscription. So what next? We just introduced our next solution, which is key shard. So you need to produce a messages, a Kafka message with the message and key. And now with the key and the key, you can decide the ordering. With the shared subscription, you can maintain the data distribution. So now we have a solution which can be ordered, which can be shared equally, and do the operation well. So here is the place. What will happen if the same problem again, like you want to get the more throughput? You just need to follow the key shard subscription. You just need to add the consumer again. Since message is having key and message value, it will just distribute the messages among all the consumers. So that all the problems are being solved with this subscriptions. So now my point is the problem which we have discussed has been already been addressed. So now you need to see messaging, event streaming. If you want to use both, welcome to the world of Pulsar. So the things what I have explained you, that is a feature which is unified messaging and streaming platform. So we do have a streaming, now we have queuing. So we are both, that's the reason I'm saying we are best in the both system. Now we're gonna discuss cloud native part. We discussed, right, cloud native because it supports the containerization system, and it just support the failure of the queuing system. The third thing is scalability. When you want to talking about scalability, you can add and remove consumer to save your, and you meet your use case and save your cost. You can also add your brokers whenever you want. You can remove the brokers. There's no impact on the existing infrastructure. You can add the bookie and remove the bookie. It's not like a heavily dependent solutions like Kafka. So let's talk about the consumer elasticity first. So let's say I have a topic, producer messages like you, which is producing messages to the topic, and M0 to M4 is consume message idle scenario. What if the messages flow is really high? How are you going to address this? Don't worry, since you are using the key shard subscription, add one more consumer. So since you added a consumer, it's not going to impact you because you use the key shard subscription. So there is no rebalancing, there is no broker involvement in it. So since there is no broker involvement, no repartitioning, no rebalancing triggered, you will not face any failure or any kind of performance issue. Next is to understand next scalability for bookie, and the bookie means broker. Bookie means bookkeeper and the broker. We're gonna discuss the Pulsar architecture slightly in deep. So we will have producer, consumer, bookkeeper, and bookie. So bookie is a kind of your storage layer. He is running on separate nodes. Brokers are running on the separate nodes. So broker is only responsible for your maintaining messages and connections to the Pulsar. And bookie is something which is taking care of your application part. So broker is directly stateless compute, and your broker is actually storage. And how we gonna address the scalability for the broker and the bookies? See, if you want to add broker to share the load and maintain the high number of topics, just as the broker, no partitioning, and no downtime required. You just add it, remove it. It's not gonna impact your existing system, just like Kafka. And let's say the last scalability is a storage one. If you want to see that you need a more replication storage, you just come and add the bookies, which is again how it's gonna manage is as soon as you add a bookie, the new messages directly go to the bookie 5. So we have 4 bookies, and I added bookie 5. So all the new messages will directly transfer to bookie 5. So in this scenario, you will not see any kind of repartitioning. You will not see any kind of broker involvement. So again, that's not a heavy operation for the bookkeeper. Now what? If you don't want to use this, remove it as it is. So again, it's not gonna create an issue for this. So these kind of scalability, if you want to achieve the 3 level of scalability for the Pulsar, recap is, if you want to scale your consumer, process the message faster and more consumer, add it with the key shard. No partitioning required for this. For scaling the broker, manage more topics and the client connections, add a broker node, no data movement, and again, there is no rebalance of data. The last is scaling the storage, store the more data, add a bookie, no new message, like you will get a new message right away without any repartitioning. So these are the common feature which makes the Pulsar cloud native. So this is why we are calling this the best solution for the cloud. Coming to apart from that, like we have additional solutions, like additional features which make the Pulsar more great compared to the other solution in the market. It's a cloud-ready architecture. Total cost of operation is very low and very cheaper to the other solutions. Multi-tenancy is already been explained by performance wise, yes. So I'm gonna especially add the performance comment in my one of the slide. We will discuss in the upcoming slides, like how the like performance benchmarking test has been done and what is the loophole. Yeah. So we'll discuss about it. So Pulsar can handle millions of messages in a second. Pulsar can having low latency, even the 10 millisecond less than producer can have less than 10 millisecond latency. It supports the tier storage. Again, if somebody follow you, which means you are doing best. Kafka announced that they're gonna do this in upcoming versions. So geo replication, we already discussed it. Scalability, we already, I think we just see the elasticity level of elasticity and function and the connector. So if you want to use and transform your existing streaming data and you want to do some aggregation operation on existing real time, just like a Kafka stream, K-stream, you can use the functions. And one important, we're gonna discuss more about the schema registry in upcoming slide with the understand the terminology of the Kafka with respect to Pulsar with respect to Kafka. And we support the KOP, which is already been discussed. We support the MOP, which is an AOP like for ActiveMQ protocols, where you just run the ActiveMQ application and you will get a data into the Pulsar. And the last and least, we are open source. When we are saying it, we mean it, because even with our organization, there are so many open source contributors and we are maintaining the open source code. So yeah, we are happy to announce that we are open source and anybody can use it, our Pulsar for freely. Yeah, so you already know more about Pulsar than you realize. If you don't know, how many know Kafka as a solutions? I think everybody know in the system, right? So let's just do understand. I'm not gonna compare it. So it's just based on my experience, how I have used and the blog post with the developer I have worked on. I concluded those points. I just want to put it, and that is based on my observation. So let's take first topic. And first topic is topic. So Pulsar also use the topic. Kafka also use the topic. What is the difference between Pulsar topic and Kafka topic? You need to make sure when we're using a Pulsar, a topic is a single to similar to the single Kafka topic partition. So Kafka topic is like, if you create a Kafka topic, it's having partition in it, like partition 0, 1, 2, 3, and it's combinedly called as a topic. In here, Kafka partition 0 as a single topic. And if you want to achieve the scalability like Kafka, you will have a provision for partition topic, which will consist of multiple partition altogether. Then what is the use case of topic? So for the specific, achieve the messaging architecture for audit low throughput applications, we have, we have architecture beyond the Kafka streaming use cases, where you can use a simple topic without any partitions, and that can help you to your audit logs. Any questions? No, sorry. So partition topic. Now, next is messaging lifecycle. If I'm talking about messaging lifecycle, I'm directly talking about retention. So if you guys already, go through the Kafka and you worried about retention, I think this is a nice slide for you. So Kafka retention policy is independent of consumer activity, which means it's TTL based. If you use a Kafka, you need to define the TTL parameters, where you need to define the timeouts specifically on respecting to that, it will delete your existing data. So what is the loophole in this? Message in a Kafka persisted first, regardless whether the consumer have read or not. I am a consumer, I want to use the consumer. My TTL expired, gone. No data for me. So how can I address this? So Pulsar is offer a greater flexibility in message life cycle compared to Kafka. And by default, it keeps all unacknowledged message indefinitely. So it's just gonna keep all the messages indefinitely. So don't worry about it. If you have a consumer, join today, tomorrow, after 1 month, if you have a policy and certain parameter defined, you can consume that. So Pulsar allow you to message retention expiry, those two parameters which you can use to maintain acknowledged and unacknowledged message. So when I talking about message retention, we will unacknowledged message will be retained unlimited, or acknowledged message will be retained by the timeout which we have defined. So to avoid the space complexity also. So you're rating unacknowledged message. So for the preventing future use, we already discussed. Okay, so the other part which we are discussing about the compaction. So compaction is a really key point which where Pulsar did right, and at the time of deletion, I think the right we have done, for that we have some constraints. So let's discuss what exactly it is. So Pulsar perform compaction on topics just like similar to Kafka. It provides you a great feature where you can consume a message from your compacted topic and uncompacted format. So if you have a compaction, so what Pulsar does is in the bookkeeper, whatever you ledgers you have. So at a ledger level, it will compact the ledgers, and you can maintain both the ledgers, compacted ledgers and uncompacted ledgers, with the help of the retention. Now, if you want to get the data from compacted ledger, you can do that. If you want to get the data from uncompacted ledger, you can do that. So that's a great feasibility is provided by Pulsar. But again, that comes with the constant they will discuss in the next slide. So a new compacted ledger is generated during the compacted. So as I mentioned, it's like you just gonna compact the ledger, and so you will have two ledgers, compacted and non-compacted. So consumer can consumer can use the property called read compacted as a true if you want to use the read the data from the compacted ledger. If you don't want to read the data from compacted ledger, you just use this property as a false. And so that's what we have discussed. So now, like, what exactly delete semantics when you are using compaction, because that's a really key feature. When if you have a compaction, so deletion is slightly tough, but Kafka really played a good role here. My personal experience, they have the tombstone where you just need to pass the key with the null value, it will delete the compacted topic data. And the next is you can put the retention that is directly applicable to your compacted topic. Here, Pulsar need the deletion key explicitly. We need to define it, and it's kind of manual process, because this is how we maintain it. And when you are just putting the retention time, I think it will just going to put on your non-compacted ledgers. So it's retention time and detail what you define. It's only for your non-compacted ledger. So how are we gonna delete it? So there are some consideration, because the feature which you have provided to access the data from compacted non-compacted use case specific, you need to explicitly you need to since all the latest key messages available in the Pulsar, you need to delete perform deletion manually. And so non-compacted ledger will have only retention, and so whatever the ledger is already been compacted, for that you need to have the manual process to delete it. And it's not heavy, but yeah, it's not just as seamless like as a Kafka. Yeah, so now we're gonna discuss schema validation for Kafka and Pulsar, and that's really important when we are discussing. So Kafka ecosystem is, if you already used it, you will have a schema registry, and you can do the schema validation from the client side. Like you can use the define a client side is like serializer, deserializer, and maintain the Kafka schema evaluation, other stuff. And your developer needs to configure the client and integrate with the registry services. And everything is done at a client side. It supports various schema flavors like Avero and port buffer and other stuff. Where the Pulsar did a really good job. They provide a server side schema, so there is no additional separate schema registry component required. No additional configuration, additional services required. We have this thing in our internal APIs which can handle this, and this is what I have explained. So it also supports the same set of schema formats. So conclusion, both Kafka and Pulsar ecosystem support schema validation and the popular schema formats, ensure schema evaluation compatibility. However, Pulsar does some good job here. They don't have any additional, you don't need to define the schema validation from a client side, because with the API it is built in and you can just need to use it. And the next thing is you will not have a separate component like called schema registry to maintain a schema separately. It's the server side. So it is very, very well maintained. Now let's talk about the producer. Again, producer is more or less similar to Kafka. The last slide I have added for ACT for the benchmark testing, which is done previously two or 3 years ago, and now recently. So that's part. So again, Pulsar, like multiple producer and like all the producer can concurrently connect to the send and message to Kafka and Pulsar topics. There is no change in that. It's behave exactly similar to the Kafka. Pulsar defaults producer access mode is shard. Again, just to achieve the similar semantics as a Kafka. A partitioning Kafka Pulsar allows controlling messages distributing key and partition. So the same. I think these are terminology we are using for the same as from the development perspective. Now, Pulsar is using default routing mode as round robin. You can change it again, of course, but yeah, again, this round robin always help to use the Kafka default partitioning behavior. So there is no much change in the producer if you are talking about the development perspective. But yeah, if you're talking about replica persistent, both Kafka and Pulsar supports the replica copies of the messages. And one good thing, replica failure handling in the Pulsar is way beyond than a Kafka because we don't require the partition synchronization before the writing a data. If you Kafka user, you know the min in sync replica, where you should have at least min in sync replicas to have to produce the messages, right? Here we don't have a concept like this. If you don't have synchronized replica also, you will be able to produce the messages. Who gonna do this? Because we have separately for bookkeeper, it's mature enough to handle these situations. So that is making things more better. And one blog I have already put as a link is a community member. He's writing blog while using Kafka as well as the Pulsar both. You can see that he mentioned that replica stack for Kafka is it's a stick of Toblerone. Is Toblerone is chocolate? It's like and for Pulsar it's expanding gas, which means replica distribution in a Kafka is much beyond than the Pulsar. Sorry, Pulsar is much beyond than a Kafka. How it's just going to happen is it expands. It use the internal algorithm, like it's maintained by the bookkeeper, and just gonna like your bookkeeper bookie layers is gonna handle it. Now, this slide I have added because I see a lot of questions when I was working with the customers, working with the solutions team, or working with the out of the people who just always doing the debate of Pulsar and Kafka. So the ACK for the Kafka, which is done at a broker level, and ACK for the Pulsar is doing at the bookkeeper level. How does it making sense? How does it making difference? If you see the benchmark test is being performed by a lot of other vendors that was saying that we want to disable fsync because we don't need it, and let's test it with the default Kafka. Default Kafka always come with the journal sync, which is also maintain the your cache at OS level. So if you want to do the apple comparison, you need to make sure whatever you disable there, it should be disabled here as well. So if you disable fsync in a Kafka, you should be disable general sync in Pulsar also. That is what we have showed in our recent benchmark test in 2022. You can download it from the StreamNative, and you see the difference what the benchmarking test. So I can see the benchmarking from the benchmark test. If you have removed all the dependency, I think Pulsar performed the way beyond the Kafka. And that's it. These are the tests we have done with the ACK with the general CTL enable, without general CTL enable. You can see it on our StreamNative side. Apart from this, Pulsar performs the optimization. Again, this is more details I don't want to discuss because it is more towards the local disk which you are using, and that's the same thing. It's been explained in the benchmark test, so you can go and download it. The scalability, horizontal scalability, we already discussed. So now come to the consumer part, and this is like consumer groups. So Kafka has a really good terminology called consumer group. They are maintaining well from their side, and similarly, we have here as a subscriptions. We can maintain all the functionality of the consumer group by using the right choice of the subscription types. We already discussed it about, in the previous slides. So ordering, so we can maintain the ordering with the failure. We can maintain the ordering with the exclusive. We can maintain the ordering with the key shard subscriptions, offset and commits. So since we are telling that Pulsar is support for streaming as well as message queuing, so Pulsar support individual out of sequence consumer message acknowledgement, which makes it good for messaging. And Kafka uses a cumulative acknowledgement that help him to maintain their use cases for the streaming, and they are really doing good with that. But now Pulsar also supports auto, just to equivalent behavior of Kafka auto commit, we have cumulative acknowledgement to be performed synchronously and asynchronously to achieve messaging and queuing both the use cases. And one more important, when I'm interacting with the people are considering or talking like Pulsar has lag. So lag in a Kafka known as backlog in a Pulsar. So that's a very funny thing I just wanted to add. So this thing, whatever I have discussed, you can get it from this article. This was one of the StreamNative developer. He wrote this, and we collaboratively discussed the board thing in detail and conclude all this stuff. So basically, topic in a Kafka is partition topic in Pulsar. Topic partitions known as topic in a Pulsar. Topic retention is retention policy plus message expiry, and Kafka does it well here. Partition replica is the replicas only. Compact topics is topic compaction. Producer by default is working as a shard. Producer acts, which is known as we have a topic policies where we are going to maintain the acts. Consumer groups can be achieved with the help of subscriptions. Commit is cumulative acknowledgement for synchronous, asynchronous, both way we can do. And schema registry, we are doing handling it as server side. So it was very short talk. So do you have any question and answer? Like you want to discuss? Yep, sure. Can we give him a mic? I cannot.
Hello.
Yeah, I can.
Yeah. I just keep hearing that Pulsar is fast. Like, but I'm not able to still digest like how is it fast? Like, I mean, is that storage model is making Pulsars fast, like sub-second latency, sub-millisecond latency? Because the Kafka does the sequential read, so it makes fast. But what is the data structure it uses to write the data and consume? I mean, what is it actually making Pulsar faster than Kafka? And that I'm still not able to get that specific, that the core thing.
It's more like yeah, it's a good question. So I mean, we are handling this data storage and the replication. So for my experience, what we see that we have a separate layer for the bookkeeper itself. So the maintenance of the replicas and the like when we are saying consuming fast, right? So we are talking about the throughput. So the throughput, like which is making faster, is you will have the replica equally distributed in the multiple nodes of the bookkeepers. That is what is not in Kafka. Like when you see that distribution of replicas is not as similar as the Kafka. So if you have replica distributions very well, it make you more scalable, more faster. But yeah, in the internally terms, what algorithm is doing, I don't have much idea. I can probably check with the developer and give the answer. Yep.
Yeah. So apart from the distribution that Vikas talked about, regarding numbers for our use case, my Grafana tells me that it's single-digit milliseconds, pretty much always. Apart from the distributed storage that Vikas already explained, the other thing I would like to add is I talked about this briefly in my presentation, where in Pulsar, one topic is always owned by only one broker. Now, broker has, if you remember the architecture, the first slide, Pulsar architecture, broker caches all the fresh data. So when the consumer comes around, at least for the fresh data, the older one, obviously it will strain Kafka or Pulsar, anything that is append only and stuff like that. So that broker meta cache or is what I think makes it quite fast in addition to the distributed storage. Yeah, but to me, the architecture with the cache makes sense that for the tail read, it will be quite fast. I wouldn't want to claim faster than Kafka and stuff like that. But there are benchmarks that I think are there in certain blog posts. If my memory serves me right, there's one from StreamNative as well, where they put all the details around how they read benchmarking and stuff, and how this is faster and stuff like that. I wouldn't want to do on a comparative thing, but for my use case, I can tell you that single-digit millisecond for consumers.
So because of this extra layer bookkeeping and the compute is decoupled with the storage. So
Yeah.
is it like multi-hops, too many layers? So for a producer and a consumer, does it add more latency in general, right? Like, because it reaches, if first it should reach to the compute layer, then it should reach to the storage layer. And that is same for the consumer. It should reach to the, I mean, it should read from the compute, sorry, from the storage to compute to the consumer. So there is one more layer added, which should add some extra network latency. Is that assumption right?
Yes, that's true. So, so yeah, there are multiple hops you are talking about, right? So how, if you are going to produce it, how is this going to maintain? So you see the, it's a called a bookkeeper maintaining the buffers, cache at a broker. So we are going to utilize that. So that is making it more effective while just producing it. But as far as the last test, which personally we have done, was like it is having less than 10 milliseconds, like producer have latency. So I think latency is not more concerned. And since it is like whatever the latency and the drawback have, we have a solution to it, like about the scalability, about the other stuff. But maintaining the buffer on top of the existing layers, I think it helps us to maintain less latency and high throughput.
So mostly the cache layer is helping.
Yeah.
Okay. So there is one more thing, like there was some comparison, the queue gets blocked.
Yeah.
In RMQ and Kafka.
Let me take it.
So I was wondering, like even in the Pulsar, when we have a subscription using the sharded, key-based subscription.
Yeah.
If one of the consumer who is consuming from a specific queue get blocked, so is that the example which we talked about in case of Kafka?
No, but let's say if your consumer gets stuck for one key, still you have different messages to be consumed, right? But it will not stop. So if you have partitions in 10 messages, if your message got stuck for 2, so for M1 is got stuck, M2 or got stuck, M1 is consumed. Less 7 messages, you will not get it. But if you have a key shard, if you have only, let's say if you're stuck with a specific key, you can retry for it, and the other messages associated with other different key, you can consume it still. So that messages which is stored with a specific partition is not being consumed, but here you can achieve it, right? Because it will map with the key.
So these messages are stored sequentially somewhere in the file, right? So if one of the message in middle got struck by reading from the consumer, but the Pulsar will go ahead and reading the rest of the messages still, is it? And the unread messages will be stored somewhere else so that it will be related to the consumer.
Yeah. So
later.
Answer to this question. So this is bookkeeper architecture. We are just going to maintain if the general CTL, like general node specific we have, which is going to handle. It's very efficient to handle those kind of failures. So it's not just a single JVM is just helping. So if you add more hop, we will have more functionality also. The general CTL, general node which is there, which is maintaining all those things. So those sort of failures can be handled at general side.
Any other questions?
Yeah. Okay.
So basically, we are using Kafka and RabbitMQ in both in our enterprise application. And so my question is related to RabbitMQ in this message queue comparison.
Okay.
So what protocol it's underlying using for the messaging? RabbitMQ uses AMQP protocol.
Yeah. Okay. So AMQ. So we have active MQ protocol, Kafka on Pulsar protocol. So like and one is MQ Rabbit, like that. So I'm aware of 3 at the moment. I use personally only KOP. But yeah, those are the sort of where you can use your existing producer and consumer code, use that protocol and produce and consume from the topics.
The second question is like, in RabbitMQ, what problem we face? Like whenever we send message to consumer and consumer did not respond.
There is no problem as such. I'm saying, so queuing, so Kafka is doing good in their use cases. RabbitMQ doing good with their use cases. There are certain use cases which Pulsar does better, and it provides both the streaming and queuing. That's what the message is.
Yeah, that's what. So instead of using both, we can use a Pulsar to accommodate both the
use cases. Can use that, and also like if you have constraint which I have explained in comparison to the features which meet your use case, I think it's the best solution.
Okay, so let's say in Apache
Pulsar we are discussing about. Once he send message to consumer, does it also wait for acknowledgement? Because it has to be guaranteed delivery message the same way how RabbitMQ.
Consumer acknowledgement or producer acknowledgement you're talking about?
No.
So yeah, so the answer to this, Pulsar supports both the I would say acknowledgement, synchronous or asynchronous. So if you're talking about consumer, it's a cumulative act, right? So it supports for asynchronous, asynchronous both. So whatever you want to choose, you can opt to that options.
So for higher messages like 10 MB, 20 MB, right? So how good Pulsar to process them?
How much size?
10 MB, 20 MB. In that case, use cases.
Yes. So so what is your use case? You want to achieve the high throughput?
A single message with or bigger message. Bigger payload.
Okay. So you want to have a file which has very large messages, and you want to. I frankly say I did not test it, but yeah, I'll check it. Do you have an answer for this, Save? So processing high memory of.
Basically, this is for queuing use cases, like where we see larger message sizes of 10 MB, even 50 MB, and all that. So how Pulsar behaves in such cases?
So we had done some benchmarks. The largest message that we had tested, this was around 4 years ago. I don't remember the exact numbers, but for large messages, it was generally, of course, slower than the smaller messages throughput, and even bytes per second. As far as job queuing case is concerned, the shared subscription where you can fan out to as many consumers as you want. And like the other gentleman had this question, right? If one of those gets stuck, then you can push it over to the dead letter queue and keep going in the job queue case. In the streaming and order required case, you can't do that, because if you get stuck, you have to be stuck, right? Otherwise you lose ordering, right? But in the queuing use case, the fan out shared subscription, that would help, right? You want to add further?
So for one particular consumer will consume that particular message, right? It's not like you will share the data in pieces and the consumer, it's not, right? So how, if you're adding multiple consumer, will increase the performance?
So what I mean is it will improve throughput. Single message latency, no. I mean, it has to go through one consumer. It probably doesn't make sense to distribute it, right? Single message, sorry, I missed that part. It will not help, in my opinion. Yeah.
We need to check. I think we need to check about it. Benchmarks. So I'll check with the. You can connect me or the community Slack. I'll just reply and check with the developers and let you know. I'm not aware as such benchmark we have done for the high number of files, but yeah, we have a benchmarks for the consumer throughputs.
Any other questions? Yeah, please keep them coming. I'll come.
This is quite diverse to what you have shared. It's regarding the transactional queue support. Does it provided into the Pulsar for exactly one semantic for writing as well as for the reading?
Yeah, I mean transitional queue support you're talking about, right? Or just normal?
Yes.
I need to check. Shiv, can you drive it? I not much into that transitions, but we support transitions.
Yeah, I mean, I have not used transactions. In general, I don't like to say that this is something that you should never do, but this is one of these things that I tell my product teams, don't look for exact ones semantics. And if you do, let's talk one-on-one first exactly about the use case. But yeah, transactions is supported in Pulsar. It's been there for quite some time, but I have not used it. So, I mean, there are blogs as to how exactly can you set up exactly once processing in Pulsar. Of course, you have to trade off with throughput and stuff, but it's there. I've not used it. Yeah. But it's there for some time, so it must be mature by now.
Yeah, recently we saw some blogs in LinkedIn from StreamNative that there is 98.3% less hardware and 100x low latency than Kafka. So is there any particular benchmark report for that from StreamNative or DataStax?
Yeah, so yes, absolutely. I have some community thread which is discussing about the same, and that is we have performed some benchmarks, and that is specific to settings which we have performed, and with the specific to the use case. I'm not sure whether the same use case you do have and you're going to achieve the same, but if you have certain use case which I can share you on the community thread, which having the same specifications, you can achieve that. And that's what it was in a Pulsar summit also. If you go to the Pulsar booth, it was there. Definitely, I acknowledge that. And if you go to the community thread, we already have a discussion around it, and that was a benchmark is been performed with especially use cases and special I would say the feature configurations, and that was achieved by one of our customer.
Yeah. So if I can add to that, Vikas.
Sure.
Yeah. If I can add to that.
Yep.
Yeah, so the two things I covered in my presentation is what I think would contribute to this in addition to other factors that I might not know. One thing that I covered or sort of explained it is the load balancer on the broker side. What it basically does is that for every broker, there is a load report that is prepared at a given cadence that is stored in Zookeeper. Now what happens is, if you have, I've not used Kafka extensively, and there are better experts there. From what I know, ultimately a partition or a topic would get stuck to one disk throughput there. Here what happens is, because of segment storage and then load balancing, what you can do is, so namespace has a group of topics. For load balancing, these namespaces are sharded. There's something called a bundle. So namespace will have a lot of bundles. Each bundle will have some topics. What Pulsar will do is, there are three brokers. One broker might be loaded. The other might be freer, right? I mean, you can't say that if you have same number of topics in the two brokers, they are loaded equivalently, right? So Pulsar will detect that from its load report. And if required, it will split bundles or the whole bundles. It can move off from the loaded broker to less loaded brokers, right? So you're moving a bunch of topics around to make sure that you don't have that situation where one broker is very loaded, the other is not. So that is one balancing where you're not letting some hardware sit with less utilization, the other one getting strained. So you have to add more IOPS or more disk or stuff like that. On the storage tier, bookkeeper side, segment-oriented storage helps a lot. So imagine a topic that has huge throughput, right? This guy is going to have a lot more segments, right? Other topic, less throughput, less number of segments. Segments are like, you can define a size, I think, and beyond that, it rolls over, regular stuff. So now you have from the loaded topic, owner, broker, more segments, less loaded, less segments. All these segments form a pool, which bookkeeper tries to spread around evenly across bookkeepers. I mean, it doesn't have real-time load balancing, but when you make segments, you keep making them frequently, right? Because you keep writing two topics. When you make a segment, then bookkeeper actually at random selects some bookkeepers. I mean, I can't 100% in theory claim that it is going to the unloaded one. From what I remember, it's randomized selection, but there again, you won't have those issues where because of one topic, one storage is getting blocked and other is just sitting idle with more IOPS provision for it. So IOPS, again, you sort of distribute with the segments from different topics. I think a long answer, but yeah, I hope I made some sense. Other questions, or can I pass on? Yeah, thank you.
Hey, thanks for that. So one question.
Yeah.
So in the key share subscription, right? So generally there is a confession hashing mechanism to split the keys and store it.
Yeah.
I mean, and assign it to the multiple consumers. So if I add one more consumer, so will it split the say? I mean, how the key sharing will happen? I mean to say that whether it will bifurcate the already existing key share, or how this, because this will happen in the microservice environment, right? Often we can scale up the consumers and we can scale down the consumer. So whether that will impact the ordering of the messages.
So
that-
your message will be associated with the keys, right?
Yeah.
So let's say if you add one more consumer, so let's say my message of chunks goes to the next consumer, which is recently addressed in terms of elasticity. So like when you just going to this is happen when you just gonna distort the message with respect to the key. I don't see the ordering gonna impacted with this. So your question is about ordering, or you the question?
Whether it will assign that same partition to the other consumer, or that partition will be assigned, I mean partition in the sense that consistent ring is, we can say that as a consistent ring, right? So that part of that consistent ring will be same to
So
the consumer.
once, let's say if you want to remove the consumer and what will happen to that key?
Yeah, exactly.
So once you remove it, I think that time it will be taken care by Pulsar. It will assign that to the existing consumers.
And moreover, how that metadata happens during the replication, because right, I can produce anywhere and I can consume anywhere throughout my geo cluster. So how that will take care? Because okay, that will store in the metadata you mean to?
No, so metadata for the specific topic is maintained for in the Zookeeper, but topic data is in the Bookkeeper, right?
Yeah.
So Bookkeeper maintains this in the ledgers. So we'll have multiple ledgers there, right? So let's say if consumer gone, like how it's been maintained. So that's why we have a separation layer over there for the Bookkeeper, which is maintaining those kind of failures.
Okay, so you mean to say that data will be stored in somewhere and that can be replicated? Because
so for the consumer specifically, we for the for consumer queue also we have a buffers, right? We will have data there as well as, and from the data perspective we'll have Bookkeeper where we gonna maintain this ledgers.
Yeah, correct. I mean, not the data, but this is the metadata, right? That, I mean, the hashing, I mean to say that. So this key to this key, it will assign to this consumer. So how that, because
that's very minimal. I would not say that it's not gonna impact it, but it's very minimal compared to the other solutions.
Okay.
It's very minimal. It's like you will see very less or minimal timing for it.